The reason why a lot of teams don't use autonomy that much is because it's difficult. Robots are hard. Autonomy is hard.
State of the art in autonomy, it's extremely challenging, and we're just not as far along as people think that we are, especially when you mix in the software and the hardware together in a real-world environment.
This is modeled after the Fukushima Daiichi nuclear power plant accident. Because of radiation, your communication link gets degraded. So if your robot has a camera, it sends a signal to your operating station. I look in the monitor, I use a joystick to send a signal. That doesn't work because the communication is not reliable. At the same time, we cannot make these robots fully autonomous because number one, we don't have that technology, and second of all, we don't trust our robots yet. So we call this supervised autonomy, which means that you give higher level commands. So human is in the loop, but the details the robot tries to figure out. So that was the original philosophy, one of the big important things about the competition. Many of the teams doesn't really use autonomy, not even supervised autonomy. Many of the teams are actually fully manually operated teleoperation. So autonomy, I think we still got a long way to go.
So interestingly enough, what we're running today for the finals is actually in some ways less autonomous than what we were doing at the trials. And the autonomy and the choice of using autonomy is again trying to find the balance between what the operator does well and what the robot does well, because they're really a team. We've shifted some of the work that we were doing on the robot over to the operator to make things faster.
I believe we've made a lot of progress in making this particular robot autonomous when compared to our performance at the trials. We added perceptual capabilities so that Chimp can automatically see things like the drill and the valve. We improved our planning algorithms so Chimp can plan the motions of its arms and its hands faster. And things along those lines speed up the task execution. Also, we have developed additional tools for the operators to use that give them better situational awareness for what's happening with the robot and provide them with a number of scripted motions that they can use in particular situations.
The most effective way of using autonomy is to bundle tasks together, to say, go do these 3 things in a row. And that gives the operator time to plan and think and understand what the next step is. There's a balance, there's a perfect balance in there somewhere for each robot, which is, you know, you can actually see some of them do it. They will very quickly go through a motion with their arms and then get into a position or like this very quickly, and you can tell they've pre-programmed that and said, okay, this is the safe position or this is the neutral position, and get into it. And it's often several steps. And that's a great use of autonomy, right? Just have it pre-programmed and say, just do this. And then use the human brain to make the more difficult decisions.
The challenge has pushed not only autonomy forward, but I think has pushed humanoid robots forward as well.
It's baby steps, right? But even 2 or 3 things that are programmed in, that makes a big difference. You can really see it.